Hi, welcome to the next episode of Physics After Hours. We have a lot to go over today, so let's get started. Alright, so here's our question right here. Our question states that we have a 2-meter diameter vertical cylinder which is open at the top and is filled with ethyl alcohol to the 2.5 meter mark. And a worker pulls a plug from a hole 55 centimeters from the bottom, causing the fluid level to begin dropping at a rate of 3.4 millimeters per minute. And asking, what is the diameter of that hole? So here's our diagram right here. We have the fluid flowing out from the hole, and we have the liquid up here. So we know that up here we have our velocity at the top as the liquid empties, the pressure at the top, and the height at the top, which is 2.5 meters right here, which I have right here. And we have our velocity down here at the bottom at the hole, which is 55 centimeters from the bottom. Keep that in mind. And the pressure at that spot as well as the height of that spot, which is 55 centimeters, which I put right here. And I've also converted that to meters as well. The question also states that this fluid level is dropping at a velocity of 3.4 millimeters per minute, which I've translated to meters per second right here. And we can also keep in mind, since both sides are open to the same open air, they're both equal to the same atmospheric pressure. And right here we're going to use Bernoulli's equation because we need to find V2, because that's the only thing we're not given, and that V2 is going to help us find the diameter. So first, let's see if we could cancel anything out. Since P1 and P2 are equally to each other, we can cancel those out. And with those canceled out, we can see that everything has the variable, which is the density of the liquid, and we could cancel those out as well. And that will leave us with this equation right here. With this equation, we want to isolate V2 since that's what we're finding. We have V2 right here, which we isolated, and put everything over a square root because it's to the power of 2. And now we're going to use this equation right here to plug into the equation of continuity, which I also got from the textbook right here, which I just divided the a to the bottom, this a to the bottom right here, and this v to the bottom right here to get this. And now that we have v2 at the bottom right here, we can plug in what v2 equals here to get this. And now we plug in their specific variables, which is the velocity 1, which is right here, our velocity of 1 right here again squared, plus 2 times our gravity, times this right here, which is what we found, y1 minus y2, which is the distance between them, which is 1.95 meters. And that leaves us with this number right here, which is 9.166 times 10 to the negative 6 power, which equals the area of the second spot divided by the area of the first spot. And with this, we can finally plug it into our other equation, or manipulate it to be able to find our diameter. Alright, so here I have the number we calculated from the last step, which is equal to the area of the second spot divided by the area of the first spot. The second spot being where the hole is, the first spot being where the top of the liquid is filled. So you're probably asking now, how are we going to find the diameter, because there's no variable for the diameter. But we can find that by, since these both are areas of the circle, so we can use the expression for the area of the circle with diameter, not radius, which is equal to pi times the diameter squared divided by 4. And we can manipulate that to be able to find our d, where the hole is. So we can put them to the respective area, because this equals the area of the diameter where the hole is, and this equals the diameter of the top of the cylinder. So that's why we have d2 right here and d1 right here. And we could see that everything cancels out, the pi cancels out and the 4 cancels out, and that would just leave us with a2 divided by a1 equals d2 squared divided by d1 squared. And since they're both squared, we just put the other side to the square root. And then we have this right here. And since we have this, we know that this equals this right here. So we just put this number in the square root, which is what I did right here. And plugging this into the calculator, I got 0.00303. And see, now we have our two diameters right here, the diameter at the hole and the diameter at the top. And actually, we know we want to find d2, which is diameter at the hole, and we already have diameter 1, which is stated in the question, which is a 2-meter diameter hole at the top. And just to make it easier for us, to find d2, multiply the D1 to the other side, and I put it into its spot. So we have 0.00303 times 2 meters, and that leaves us with 0.0061 meters, or translated into millimeters is 6.1 millimeters. And that is the diameter of our hole.